Okay, practice exam number 2. I'm going to work very select questions because a lot of them are already in other videos like integration by parts, trig substitution. I mean, I worked so many of those. However, I do want to go over some that in particular. I'm going to do G first because I want to discuss how I have the exam set up. So the first thing, there's going to be two integration by parts together. So there's going to be one like 1A with the ln. The ln is the easy one. I mean, if you screw that up, it's your fault. But this is the more difficult one because this one involves a U substitution that I told you to do in your head. So I'm going to do this one. So first, again, you identify the U, the dv. So remember, you always choose the U according to the weight, right? So you are going to have one where you have the logarithm one there. And then algebraic always beats trig or exponential. So since I have a trig function, that's what I pick next. All right, and I should put the dx here because this is the derivative. This is not the derivative. So then I take the derivative of 4x, which is 4. I have to do the antiderivative. So this is the tricky part. You have to be very careful. So I know the derivative of sine is cosine. So I know that I'm not going to have a sign change here. So I'm going to put sine 2x. But I know that the sine 2x, the derivative of sine 2x is cos 2x times 2. And I don't have it there. So remember I told you the trick. Just take whatever number this is and put 1 over that there. Okay, so now I'm going to do uv minus integral v du. So I do my uv, which is 4x times 1/2 sine 2x. I don't like the way my n looks. Minus integral v du. So I'm just going to do it. Half of 4. And don't forget the dx because it is a derivative. So here I neaten this up. Please, please do not leave this like this. Half of 4x is 2x. So this is done. That is completely finished. All I have to do is integrate this, and I have to be very careful. I know, again, that the derivative of cosine is sine, right? And again, I know that my answer is going to be cosine 2x. I mean, I know that. I know the derivative of cosine is negative sine. Whoop, there it is. So you have to be, this is really tricky to get this right. Also, I told you that, this is a U substitution. The derivative of cos 2x is negative 2 sine 2x. I mean, look, that's exactly what you have there. You already have the 2. That 2 comes from the du from here, right? You have to take the derivative of 2x and put it there. So you get a 2. And the sign is even correct. So this is actually going to be plus. If you take the derivative of positive cos 2x, you get negative 2 sine 2x. And then the plus c. But again, this is the trickier of the two integration by parts problems. Okay, so it's not that bad. Just have to be careful. Make sure you divide by whatever you see there. So this might be a 2, this might be a 4. The only way that I'm doing this differently is that I just change the numbers around. It's not going to be a completely different problem. It'll be just like you see here. I will literally just change these numbers. That's all I will do. Right? I have to put an x here because if I put an x squared here, you'd have to integrate by parts twice. Now, the variation, I'm going to do something like this, and I don't know if I have it on the sheet, but I want you to understand. You have something, I can't remember what the hell I had there. What I have, E? Okay, I had this on the sheet. This was J. So this, you're going to have 4 blanks to fill in, and this is it. This question is incredibly difficult. You cannot integrate this by parts. Even twice it fails. You have to do trickery with this one. You do integration by parts once, will fail. You'll have to do it a second time, and then you have to do that weird thing where you set it equal. And I would never make you integrate this. However, on the test, all I want to see is that you correctly identify the U, that you understand that that's that, and then the dv. And then I want you to find the antiderivative of this. Now, again, it's e to the u. The du is right there, 1/4. Simple. And then you take that derivative. And then it is over. This is what I'm looking for. That's it. It's going to be, you're going to have a very short amount of space, and it's 4 fill in the blanks. So that's the third integration by parts problem. You had one with log. you have one like the problem I just worked, and then you have one like this. It's a separate question. The other one is just A, B. You do those two. This one is just fill in the blanks. You're not doing it. You're not going to do it. I don't want you to write UV, DV. You don't do any of that. You just tell me the U and the DV and integrate and derivative, and it's over. It's all you do. All right. That question is worth 4 points. 1, 2, 3, 4. Nothing else. Not integrated. You do not set up the formula. I don't want UV. I don't want any of that. It's over right there. So that's how that part of the test is going to be presented. Now I'm going to jump over here to L because I know that I'm going to ask something like this. The long division one. There's only going to be, well, I mean, there's 2 of them on the test. There's only going to be one like this. Man, you see, that's not how it's going to be though. Let me do it the way it's going to be. I know that I have a cubic one, but I have to do a different one. Oh, that was I. Oh, apparently I can't read the alphabet. It looked like an L to me. Okay, whatever. So it's all good. I'm going to do this one, but I'm going to explain to you why I'm going to do it after I do it. So long division. You write the polynomial down. Okay. I don't think I made a video for this yet. I didn't have time. So you're going to divide the first guy by the first guy, right? 6x2 divided by 3x is 2x. That's how you determine what goes up here. That has to distribute to both of these. You're always going to make a copy of this guy. And then 2x times -1 is -2x. Now I'm going to switch my signs. Oh, man, my red died. Oh, well, maybe green works. Green doesn't work either. No more colors. Okay, fine. Plus, circle it. Minus, circle it. I circle the sign change. So you have 13 and 2. Make 15. X. And then drop the -1 down. So now again, first guy inside, first guy outside. Take him, divide it by him. 15 divided by 3 is 5, and the x's cross out, so you get a +5 here. So 5 times 3x makes 15. I'm going to switch the sign in a minute, and then +5 times -1. And then I'm going to switch. I circle the sign change, so I know that that's what I switched to. 5 take away 1 is 4, so my remainder is 4. So when I do this division, so this was the original question. I wrote it lazily. So after I do this long division, I get integral. That thing is equal to 2x plus 5 plus 4 over 3x minus 1. This is such a terrible question because this isn't how it's going to happen on the test. I picked a bad number here. I should have picked something else. We're gonna cheat and we're gonna repair it because I'm gonna show you what I have on the test. Let's pretend that it came out to 3. It didn't come out to 3, but let's pretend it came out to 3 so you can see the one that's on the exam. Integrate this, you get x squared, right? Add 1 to the power, divide by the new power. Integrate this, you get 5x. Now this is, because this is what I'm going to do on the test. I will make sure that your remainder matches up to the bottom, right? You already know that, well, hopefully you remember, because I did this in class, when you take this derivative, you put this on the bottom, right? Du over u. That's the u. You put this on the bottom and his derivative on the top. This is already what I have. What I will see students do, though, is they will just put plus 3 ln 3x minus 1. This would not work because if you take this derivative, you get that times 3. So you'd have a 9 on the top. It just doesn't work. So this 3 cannot be there. So the one on the test, first of all, let me just do it so that it'll look like what it's going to look like on the test. It's going to be a cubic. That's why I was originally wanting to do the one with the third, but then I realized that it doesn't make sense because it's not. You're going to have something like 6x to the third plus 5x squared minus 7x plus 1, whatever, and you're going to dividing by something like that. And then when you finish the question, you'll get 3 things, and you'll get a remainder just like that. And you have to remember that there is a 1 here. This derivative is already there. Now, if there was a 6 here, then you would put a 2 there. If there was a 9 there, then you would put a 3 there. But I already know how I'm going to design the one on the test. It's going to look just like that. It might be 2 over 2x minus 1. And then that's just ln 2x minus 1. It's not 2 ln 2x minus 1, right? This derivative is that. You don't need to adjust it. So this is the way that it's going to appear on the test. It will be cubic. So it's going to be an x to the third squared, and then an x and then a number. So you will have the four things. You're going to be dividing by something that isn't a 1, and you'll get that. You're going to get that as the remainder to see if you do it right. Okay, pause here. All right, so I'm going to kind of do the trig ones simultaneously so you can understand. I have two of them. Again, I grouped the integrals on the test the way by the technique they're used. The two integration by parts ones are together. There's another integration by parts one where you fill in the four blanks, the u to dv, the du, and the v. You just fill in those four blanks and it's over. Don't integrate, do anything else. You're not going to have space to do anything else because I won't leave you space to do anything else. And it's going to say in parentheses, you will lose all 4 points if you attempt to integrate it because you can't. I'm going to give you one that you can't integrate. You can only identify the u and the dv and that's it. And then you fill in all the blanks. So integration by parts are grouped together. The long division one, there's only one normal one, then there's a definite integral one, but so that one is all by itself. And then you have the trig ones. These two that I wrote there will be together, the sine and cosine one and the tangent one. Now, there are 3 types of these because there's 2 types of these that we did. This one is easy that you would split apart the cosine. And again, I'm just going to start it just to show you things that you should do and you shouldn't do, right? So that's going to be the du. So that means that the u is sine x. That means I have to get rid of this. So you put 1 minus sine squared here, where the cosine squared is. I distribute it. So that's going to give me sine to the 9th minus sine 11 times cosine dx, right? I get that. At this point, you put the u there. Do not put the u too soon. And also, you don't see what students were doing was this. They were putting du right here on the quizzes. This makes no sense. You can't put du here without putting u here. So you have to, it's all about writing it properly, right? You have to be, I mean, it's calculus too. You have to have some level of precision when you do the work. So you're going to do that there. And then this is over, right? It's 1/10 sine 10 and then 1/12 sine 12. So that, you don't need to see me finish this. I just wanted to start it. So you have one and only one with sines and cosines. There's no reason, these are very redundant. They're done the same way. It's just you split up whichever one is odd and smaller. Right now, the tangent and secant ones have 2 different methods of doing them. One is if secant is even, and one if secant is odd. Now, if secant is odd and tangent is not odd, then you got a big problem in. Why would I do that to you? You guys, none of you would be able to integrate it correctly. None of you. So there's no reason to do that to you. This one, since secant is even. Now, when secant is even, it does not matter if tangent is odd or even. It is irrelevant. You don't even care about tangent. If he's even, he is the one you split up. And then again, you go through this game, right? This is your du. So that means that your u must be tangent because the du is secant squared. And then you play the game. You have to get rid of, you're going to put tan squared plus 1 where secant squared is. So you end up with tan 10 plus tan 8 times secant squared. Man, that 8 looks so crazy. Okay, 8. Having a problem writing my 8s today. Now you would do u10 plus u8 times du, and then again you would integrate it from there. You don't need to see me go past this again. So you have 2 like that. Now, the other method of doing the tans and secants is if they're both odd, right? If secant's odd and tangent's not, if tangent is even and secant is odd, it's over for you. So I'm just assuming they're both going to be odd. I'll make secant odd, and hence I must make tangent odd or I screw you over. So I won't do that. So let me quickly write that one down. Okay, so now the one on the sheet, I'll be honest with you, was not what I wanted. I think I had 10-5 there. It's no good. I'm going to give you one where they're both odd. So you're going to pull off one tangent and one secant. And then you get your secant tangent at the end as the du, right? So so the way that I had to do this, because I don't want ABC. It's convoluted in terms of spacing out your test. So I separated this one out from the other 2. So it's just all by itself as a separate question. And I think I have it worth 4. You split it up correctly. You identify the U, the DU, you make your substitution, you go do it, so it's not a big deal. But so remember, if this is DU, that means that the U is secant. This is really important because if you misidentify these, right? I don't want to write. It's too much writing and it's taking too long. I already don't want this video to be super duper long. So that means that you have to get rid of tan. So you have to make sure you put the right identity there. And yes, I'm going to give you the sheet with every single trig identity, in particular, the ones you will use. See, now I do totally get why people will put DU here because it's a lot of writing and you want to be a little lazy. So you just put the DU there, but you only do it here, right? I mean, if you really want to do it now, I can do it now. You could put it all in there now and then distribute that and then get U4 minus U squared du. I'm okay with that. And then you'll get 1/5 secant to the 5th and then 1/3 secant to the 3rd. Again, you don't get this far. You know what you're doing. You don't need to see the rest of it. So that covers the predominant thing. Now, there's going to be 2 trig substitution integrals. Now, I am not working them because, one, they take a long time, and I made 4 trig substitution videos. They are not different from the ones here. I will go out of my way. When I make the problem up, right? How do you recognize them? They're impossible to mistake for anything else. They're fractions with radicals in them. There's nothing else like that on the test. And I will have 2 of them together. A, B, 5 points each. That's 10 points. So you have to make sure that you, like in this one, you have to recognize that this one, I got to get the 2. This one is going to be secant. If this had been a plus, it would be tan. And if it was flipped the other way, if it was 4 minus x squared, then it would be sine, right? I have to get each one. I have to ask all of them, and I'm going to. I have to also make sure that this integral does not come out to be something horrible. Like if you do this whole question and you end up here, this is disaster. You can't do this, or even something worse that you couldn't possibly do in a million years. I even got stuck doing this integral. This is incredible. It looks so simple, but it's so hard. You have to integrate by parts twice. It's insane. I have to make sure when you set up your trig substitution and you do it correctly, that you get something reasonable to integrate. Now, you might have to do, you might end up here. And you have to understand that if you get 1 over secant, that is cosine. You might end up with something like tan over secant, and that's okay too. You have sine over cosine divided by 1 over cosine. Now, if you know what you're doing, right, keep, change, flip, whoops, and cross those out. So this would simplify to just sine, right? You may have to do a little manipulation to get it to where you can integrate it. So, you have to be able, that's why I give you all the identities. So they're going to come out reasonable. Why am I telling you this? This is really important. You get this question on your test and you get to the end and you get something that you cannot integrate, then you effed up somewhere in the trig substitution and you made a mistake. So if you get something like secant to the 3rd, which is impossible to integrate for you, too complicated, right? You have to get integrals that you can do. Now, you might end up with something like this. And you're like, but we don't know how to do that one. You absolutely do. You use the identity for tan squared. There you go, right? Like if you ended up with something like this, you just put this there. The integral of secant squared is tan. The integral of 1 is just theta. In fact, that's a really good question. Could get something like that. And you make that's not difficult to integrate. You have to know to replace the tan squared with the secant squared minus 1. That's the identity. That's what it's equal to, right? Tan squared plus 1 is equal to secant squared. So if I want to get rid of tan, I put that. So the point I'm making is the first 2 trig substitution problems I give you will work out fairly nice. All right. But and again, this is pretty, this is the whole test. The integration by parts Three of them all together. Two that you're going to do all the way. One where you just fill in the blanks with the U, the dv. You can see my lighting is going bad late in the day. So what can you do? Then you have a trig integral with sine cosine, trig integral with tan secant. You have another one that I just separated into a different question with tan and secant again, right? There's only two varieties of those. Secant is even, secant is odd. And then you have the long division one you can do all by yourself. And then you have the two trig substitution. And then you have this monstrosity. Now, I am going to try to do it just to, because to be honest, I have no idea how it comes out. And I need to see how it comes out. So I'm actually going to work this question. So, but you have one like this. Now it's worth more. I think I originally have it with 6. Because really, if you do the trig substitution right, you get it. That's 5 points out of 6. And then if you just plug in wrong and F it up, who cares? It's 1 point. I was debating making 7, but I think it's going to be 6 altogether. So really, you only get 1 point for plugging in and getting the correct answer, meaning you'll only lose 1 point if you F that up royally. If, in fact, if you decide that you don't even want to plug the numbers in, you still get 5 out of 6 points. I mean, more or less. All right, so this is going to be tan. Now notice that was very nice. I made it a 1, so it's easier to do. So that means that the derivative is secant squared d theta. Remember, you're switching variables. You're not putting tan x, it's tan theta. So I'm going to put everything in. I have to keep my horribleness here. All right, so secant squared is going to go on the top. Now, so here's where I am going to cheat. I have to put my d theta. I know that this is going to be tan squared plus 1. I know I'm going to replace it with secant squared, and I know I'm going to get secant, so I'm just going to jump and put that there. And I have a 3, right? This is very important. The radical part of this comes out to secant, but you still have to deal with this third power. So on the bottom of this, I'm actually going to have secant cubed. And this is awesome because those two will cross out 2 of those and leave me with 1 over secant, which is just cosine. I mean, that's like you cannot get any better than that. So after I do the trig substitution and I do my crossing out, I get 1 over secant, which is cosine d theta. So when I integrate that, I'm going to have sine theta. Now remember what we discussed. These are not true anymore. And I have to put this back the way it was, and then I'm going to plug in radical 3, and then I'm going to plug in 0. So I need my triangle. So remember, I know that the tan of theta is x over 1. There's no 1 there. You have to put it there. Remember, the tangent of the angle is the opposite over the adjacent. So, the opposite side is x. That means the adjacent side is 1. So, right, opposite, adjacent. And the missing side is always what you started with in the problem. My 2 is not looking good. Okay. So you always take the radical from the original question. So I'm not going to even write that there. I'm going to immediately do sine, which is opposite hypotenuse. And now I'm going to plug in 0 and radical 3. I mean, you see that it's actually not that bad. It's actually not different from what you just did, except you have one more step to do after you've finished doing the integral, right? After you put the x's back in, you do your trig substitution, you simplify it, you get here, you integrate, and then you put the x's back using your right triangle. So now I'm going to put radical 3 first. Radical 3 goes on the top. Now, radical 3 has to go here, inside the radical. Radical 3 squared is 3. Plus 1 is 4. So I get 4 there. That's by design. Now, minus, now 0 is a gift here for you. On the bottom, now this is really important. You can't get 0 here. This would make this integral a very bad enemy of ours, which we'll talk about later. That would be what's called an improper integral. You cannot have the 0. So you get 0 over 1, but that's fine. 0 over 1 is 0. So that whole thing is gone. So my whole answer to this question is just radical 3 over 2. So really, you get an extra point for doing that. Is it really that difficult? It's not. I designed it not to be difficult. I don't want it to be hard to do. And I don't want it to be hard to compute at the end. Look, I have to find a way to test all of them. And I do need to make sure that you can do the definite integrals. On the final exam, there's volumes, there's areas between curves. You have to be, you're going to be doing definite integrals. And then we are going to be doing improper integrals. So we're going to be doing things, weird things, things with infinities in them, things where the numbers on the bottom come out to zero. So it's like, I don't want you to forget how to do this. So I have to make sure I keep asking it. And then the one more question that I have there. Now, this is the one I'm going to try to work the one on the sheet and see if it comes out the way that it's supposed to come out. And if it doesn't, then I'll tell you how I do it on the test. So let's see. I actually don't think this one is going to come out the way. What I was debating was making this question on the exam. It looks like an 8. It's getting dark in here. It's hard to see. I was debating making it come out evenly so that when you do the long division, you do not get a remainder, and then you just plug the numbers in. I mean, either way, it doesn't matter. I mean, I'm gonna do it the way that it is and see how it comes out because I'm curious, and then I'll tell you what I'm likely to do on the exam. I mean, I might leave it this way. So there is a justification for leaving it this way. Again, divide the first guy. There's no reason not to do this on the side. Take the first guy and the first guy, divide them. So you get 2x. 2x. 2x times x, 2x squared. You're always going to get a copy, and the signs will always be the same because you're going to subtract them and switch, right? Remember, long division is subtraction. So then you're going to do 2x times -3. And then I'm going to switch that sign. I'm going to switch that sign. Those will always cross out or you screwed up. I have 6 x's. I lose 5. That gives me 1x. I drop the -8 down. Now I'm going to divide x by x. That gives me 1, positive 1. 1 times x is x. 1 times -3. Whoops, it's -3. I made this trademark. Now again, you're going to subtract, right? You are subtracting this whole quantity. Students screw this up. That's why I tell them not to do that. That's why I tell them just take whatever you got and just switch, and just circle the new sign. Those cross out. +3 take away 8 is -5. So this one did have a remainder of -5. So when you rewrite the original integral, when you do the long division, you get 2x plus 1 minus 5 over x minus 3. Evaluated at 4 and 5. Now I understand exactly why I picked those numbers, and I'll show you in a minute. Integrate this, you get x squared. Integrate this, you get positive x. Now remember, this does not have a number here. This is not a 2, this is not a 3, there's a 1 there. So if you take the derivative of ln x minus 3, if you take that derivative, right, you get the derivative on top, which is 1, and you get x minus 3 on the bottom. So I can just take that -5 and keep it in the front. So that's exactly what you do. You put -5 ln x minus 3, and then I'm going to evaluate that at 5 and 4. So I'm out of room. I don't need all this there. So note, I want to see what happens when you plug 5 in. So you're going to put 5 here and here, right? You get 5 squared plus 5 minus 5. A lot of 5s here. Jesus. 5 ln 5 minus 3. Take away. Then you're going to plug in 4, right? You get 4 squared plus 4 minus 5 ln 4 minus 3. Here's the whole catch to this stupidity. Here you get ln 1, which is 0. So that whole thing goes away. That's why it's there. That's why I picked that number. So here you get 16 and 4, which is 20, right? And you would do -20. Here you get 25 plus 5, which is 30. So you can do 30 minus 20, which is 10, and then you're stuck with this. You can't do anything with this. You just have to put -5 ln 2. And that would be it. Don't do nothing dumbass like do 10 minus 5. I am debating it, leaving it. That's why the reason I finished it is because I'm debating leaving it like this. Because you know what? This is fine. And then it shows me that you understand that the ln of 1 is 0. Yeah, you're stuck with this. You know the calculator, and even if you did, the calculator gives you decimal approximations. Not the ln 2 is as precise as it gets. It's just like pi squared. Like pi is 3.14. No, it's not. Pi is infinite decimal. It doesn't repeat. You know, the best thing you could write for pi is the symbol pi. So same thing with radical 2. It's like 1.4 radical 2 is radical 2. So ln 2, God knows what the hell that is. It's whatever. Who cares? It's just some number. So you leave it as ln 2. You wouldn't be able to compute it anyway. So I'll either do it just like this, or I will have the remainder come out to be 0, in which case this wouldn't even be here. And then you would just plug in to here. And now that I'm thinking about it, it's kind of stupid and pointless to do it that way. But, I already had you do one on the test where you will have a remainder. So maybe I'll make this one also have a remainder. I'm telling you, I haven't decided yet which way I'm leaning either. And I have only 2 days to decide what to do. But, it's safe to assume that I would do it this way. So you should make that assumption that I will leave it like that so that you will have this there. And then you'll just have to plug into that. And still part of it goes away because you get ln1. So I don't think it's unreasonable. And that, it's a lot for one test. My test used to be longer, but you know, the integration by parts, there's two that you're going to do all the way. There's a fill in the blank one. There are three integrals total with trig. Only one sine cosine, two with tan and secant, because there's two variations of that, so there's three of those. You have the one long division, which is going to be cubic one. And I will make sure that the remainder, that's the one, whatever you're dividing by, if you're dividing by, say, 3x minus 1, I'll make sure the remainder is 3 to see who's going to mess that up. It's very easy to get that wrong. So I'll have something like that. And again, trig substitution, there's two of them, and then there's one as a definite integral, which I did work and show you that it doesn't work out that bad. It's not so horrific that it's that it's undoable. And then this there. So I mean, altogether it's like 7 total questions, but that exam will literally take you every minute of time that you have. So, I'm trying to, give you all the secrets to what's on that test. So at least, the video is moderately helpful. So, I didn't want to just sit there and just work every single question. I want to explain how I'm designing your test and what to look for, what exactly you have to do and what you have to know. I mean, really, if you're having trouble with those trig substitutions, watch the, I mean, I worked 5 of them in those 4 videos and I wrote notes up there. So there's notes to look at and, you have the videos for the trig substitution. You practiced it a lot. You guys did the homework. I was looking at them for the most part. Some of them, even in the homework, some of them worked out very nasty. Believe me, your test is designed not to come out nasty. So, hopefully this was of some help. So good luck on a very hard test.